As we prepare for solving systems of two linear equations, we're going to remind ourselves about the special cases when we're solving regular linear equations. Okay, so recognizing inconsistent equations and identities, that if you attempt to solve an equation with no solution or one that is true for every real number, you will eliminate the variable. So when you're doing the work of like giving everything with x on one side, everything else onto the other side, all of the x's will cancel. Now, for an inconsistent equation with no solution, that will result in a false statement. So when the variables all cancels, you'll get something like 2 equal to 5. So all that's left is a statement like that, which is a false statement. Now, an identity that is true for every real number results in a true statement, so that when the variables cancel, you end up with something like 4 equal to 4 or 0 equal to 0. So let's look at a couple examples. So if you remember, if you're solving a linear equation like 2x plus 6 equals to 2 times the quantity x plus 4, the first thing you might want to do is to distribute, get rid of the parentheses. So we would have 2x plus 6 on the left-hand side, and then distributing the 2, that means multiply each term inside the parentheses by the 2. We get 2x plus 8. Then let's get everything with x onto the left side, so let's subtract 2x from both sides of the equation. And so what we'd end up with is, well, 6 equals to 8. And then if you think that's true, well, I'll give you $6, you give me $8, and that would be true, right? No, it's false. So this is a false statement. And what this means is that there is no solution for that equation. Now let's look at this next example. To solve the equation 3 times the quantity x minus 1 plus 9 equals to 8x plus 6 minus 5x. So let's distribute and also combine like terms. So distributing the 3, we go with 3x minus 3 plus 9 equals to, now on the right side we could do that 8x minus 5x, so that'll be what, 3x plus 6. Combining the like terms on the left-hand side, so that negative 3 plus 9, so we get 3x plus 6 equals to 3x plus 6. Obviously, those are equal to each other, no matter what x would be. But also, again, if we were to subtract 3x from both sides of the equation, we would end up with 6 equals to 6, which is a true statement. So what this means is that x can be any real number. Now the reason why we bring this up is when you're solving a system of two linear equations, you're going to have 3 possible cases. Now look at it graphically. Now if we graph the two linear equations, one possibility will be that the two lines intersect at one point and there's exactly one solution. So you'll have a solution. Now another possibility would be something like if they were parallel lines but distinct lines, then there is no point of intersection, so there'd be no solution. So when you're doing the work of when you're using the methods like the substitution method or the elimination method, you'll end up something like what we got before, but we end up with an equation where the variables all cancel, but we end up with one number equal to a different number. Now the other possibility would be that if you graph the two lines, that they actually are the same line, and that means that there's going to be an infinite number of solutions and that every single point on the line is a solution to that system. And what will happen when you're trying to solve that algebraically is you'll have something like what we just had with this equation, where all of the variables will cancel and you'll end up with one number equal to itself, so you'll end up with that true statement.